So as we look at this car class, it's not a very realistic model for things, is it? Why is that? As we drive it, each time we drive, we increase the miles and we reduce the gallons. What happens when we keep driving it over and over and over? The number of gallons is going to keep decreasing. It's going to dip below zero. Should a car be able to have negative 20 gallons in its tank? No. If we were going to expand upon this assignment, maybe as a second iteration for it for a different grade, we'd want to put some limits in it. Stop the car from driving once it doesn't have any gas. Then what? Is it just all done? Well, you might also want to add a fill method to it that would put more gasoline back into it. So right now, the car, it doesn't look like we have any use of a sample of how to use it. But right now you do car, car C1 equals new car, and then C1.drive, 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 C1.display. Eventually it'd hit the point where it shouldn't be able to drive any further. You ought to be able to check to see how many gallons there are in it. Then you ought to be able to change the number of gallons in it. Same for that rat. Maybe there's a theoretical limit to the size that the lab rat can grow. We had our lab rat class. Let's see if I can find it real quick. It's okay if y'all don't update it in this fashion that I'm about to do, but I at least want you to see this. I want you to see NetBeans loading. It's exactly what I want you to see. Rat. Here we go. So each time we grow, we add on to its weight. But what if there was some theoretical maximum size for a rat? There aren't rats the size of Doberman pinschers. Hopefully not. So inside the grow function, we might check to make sure that the weight hasn't exceeded a maximum value. So we could put a check in there. If the weight is less than the max value, which we haven't defined anywhere, so that's going to be a syntax error, then and only then increase its weight. That kind of thing. So what we can do is we can make sure that our class always maintains a valid set of information. All of the variables that are contained in that class at any one moment in time, they all have values, and those values are called its state. Just like you have an object on the screen and it has an X position and a Y position and it's got a pixel color. That's its current state. Well, this rat has a current state consisting of its age and its weight and its growth rate. All three of those things are the current state of it. If you wanted the ability to save a rat and then load it back into memory for further playing with, you would need to implement some sort of file I/O where you could write the rat state out and then later on you could read it back in. Just like any video game you play, you stop playing and then you come back, you load your character back in, and you don't have to start from fresh anymore. That kind of went out, with the days of the old, 8 and 16-bit computers. Game machines. Nowadays, you're expected to be able to save your information, not just start from the beginning each and every time. Well, all your save information for this object here would be all the member variables, all the instance variables for that object. Go ahead and do open up NetBeans, and we're just going to play with some of the ideas that we haven't already done here, which is the ideas of getters and setters. So make a new project. And I think we already We did a bottle as an example class, so, something that had a volume. Does that sound right or wrong? Well, we'll do it again. Alrighty, so we're going to make a class called bottle. And why? Because we want to be able to do something like this. Don't type this in yet. I mean, you can in your main, but it's not going to work yet. Bottle B is equal to new bottle. B.fill, and we're going to fill it up with, 20 ounces of liquid. B.pour, and we're going to pour out 10 ounces of liquid, and then B.display. We want to see what the bottle looks like after that point. That's all the stuff that we want to be able to do with our bottle. So what kind of state information do we need to maintain about it? What is its instance variable going to be? I say volume, the volume of liquid in it. What are other things that we might care about the bottle? The max volume. One is the amount of liquid in it, and the other is the max. And you could have a 2-liter bottle with only, 0.1 liters in it, or ounces. Well, I called it ounces, and now I'm calling it liters. Let's go for ounces the whole way. You could have a 32-ounce bottle, and, only 10 ounces actually filled. So when you make your bottle, you might want to be able to set its max. Okay, my bottle can have a maximum value of 40 ounces, but I'm going to fill it up with 10, then I'm going to pour 10 of them out, and then I'm going to display it. Let's make a class that supports those. These are, I'm just going to kind of make it myself a little cheat sheet, if I can. These are going to be my so-called behaviors, my functions. If I was going to make a UML for it, the top line would be the name of the class. And then, we'd have a row of things, and then we'd have some variables in the next line. Right now, I can only think of 2 of them. The max volume, and then the current volume. And then we would have, so in your UML, the top one is the name, the middle section are the variables, and the last one are the methods. So we know that these are going to be our methods. And we know that these are going to take values. Right? And those amounts could be floats or ints. We haven't really picked what type of data they need to store, so I'm going to leave them like that. And remember that on our UML documentation, we said that if something is prefixed with a minus sign in front of it, it means that it's a private variable that the calling code cannot get a hold of. Same for functions. If you put a minus sign in front of a function inside the UML, in front of the function name, then it means that the calling code can't access it. So typically the rule of thumb is make your data private, and then make your variables private, make your data private, and then make your methods public. It's a rule of thumb. Data hiding, data encapsulation. Let's go and actually make a class that does some of this. So I'm going to go to my project. Whoops. I'm going to remove my package statement. Fix my package error. Move class to correct folder. Then I'm going to go back out to my project listing. I'm going to right click on default package and do new Java class, and I'm going to make a class called bottle. And we said that the bottle needs 2 variables, a max volume and a current volume. So private max volume, except I didn't give it a type. Private int max volume. I can make it double, doesn't matter. And then private int current volume. Now we need to put some methods in there that will interact with that data. A class is a collection of variables of data and the methods that act upon it. So if we look over here, what were some of our methods that we wanted? We wanted a set max, a fill, a pour, and a display. All right, so public, and none of these need to actually return a value so far as we know. That means that we're going to declare them all as void. So in our UML, we should have been specifying that none of these need to return anything. Maybe we'll decide that pour should return the amount that was actually poured out. That might not be a bad idea. But for now, I'm going to leave them as void. And they're going to be public. So public void set max. Is that how I called it? And it needs to take an amount in as an argument. So we need a parameter. Parameter named, oh wait, what do you know, I didn't make him accept an argument. Now I did. All right, so 3 of these are going to need parameters, right? When you set the maximum, how much you're filling it with and how much you're pouring out of it. So int amount's going to be the name of the parameter, amount is the name of the parameter. It contains the amount of fluid that we're putting into it. So once we do that, this dot max volume is equal to the amount that we just specified. And let's print a message. You don't normally want to make your classes noisy, whether each time you access it, it prints out a new message. So these are more like debug messages. We'll probably go back and remove them. So I'm just going to put the word debug there to kind of remind myself of that. Debug colon max volume set to end quote plus this dot max volume. And you can put it all on one line, obviously. Now let's do the same thing for fill and pour. Fill is going to change the current volume, and so is pour. Because when you fill it, that doesn't change the max volume. I guess unless you're filling a balloon with air. I don't know. So public void fill, and it needs a parameter, how much fluid we are inserting into our bottle. So this dot cur volume plus equals the amount that we passed in. For now, I'm going to make the debug message just really short. All I'm going to do is put filled, debug, colon, filled, end quote, plus the amount. Doesn't tell us much. Doesn't tell us the current volume. We can call the display method that we're going to write to figure out what the current volume is. So public void pour. How much are we going to pour out of it? So public void pour, parentheses, int amount, end parentheses, curly brace. This dot cur volume minus equals amount. System.out.println, debug colon, poured, space end quote, plus amount in parentheses semicolon. And then lastly, a display method. So we can get some information about the bottle's current state. Public void display. This one doesn't take any arguments, so we don't need any parameters. Let's just print 2 pieces of information out. System.out.println bottle, max volume, equals plus this dot max volume. And then on the next line, same kind of deal, bottle current volume equals plus this dot current volume. I'm messing something up there. Yeah, I am. Forgive me while I move things around. Instead of even reading it out. I'm going to type it first and then let you just see what I did. Okay. That's a really stupid way of doing it. I was trying to make it look clear. I think we've talked about printf. So what I'm going to do is I'm going to rewrite that to use printf. So system.out.printf bottle max equals %d space current equals %d \n, then a comma, and on the next line this dot max volume, comma, this dot current volume. All right. Now if I did this exactly as I think I did, I should be, after I hit Control S to save it, go back to my original, and yay, all the errors are gone because I did correctly create my methods. So I'm going to run it. See what it does. Max volume set to 40, filled 20, poured 10, so the max is 40 and the current is 10. Let's take those three lines, the fill, the pour, and the display, and paste them. Copy them and paste them in 2 more times, like that. And heck, let's add them a couple more times. Alright, so I've got several iterations now here. We fill it with 20, we do something, we filled it with 20, we filled it with 20 a third time, a fourth time, and a fifth time. So I've actually got 5 of these method call blocks in a row. I'm just numbering them. You don't have to do this, but just so that I can keep track in my head of that. And I want to stop here and I want to make sure that everybody's got this going right now. What I want you to notice is that the way we've written this, it winds up containing more than the maximum volume. Think about how you could prevent that. Just like I mentioned on the lab rat, we could stop the rat from growing past a certain body weight. There should be a place in your class where you could limit the maximum amount. Where you could limit the amount, the volume of the bottle to what it is current, what its max volume is. So think about that. So what method do I need to change to prevent us from overfilling the bottle? Yeah, I'm going to do it in fill. And thinking about what I need to do is I could check the current volume to make sure that it wasn't greater than the max volume before we started filling it. Or I could do it after we've already added to it. We can make this as simple or as complex as we wanted. Here's what I'm mean by that. How did y'all do it? Somebody's actually got the fix already in. What did you do? Nobody wants to tell me. Yeah.
I said if amount that you're passing into it plus the current volume is greater than the max volume, you don't fill it.
Yeah, exactly. That's one way to do it. Another way would just be to go ahead and fill it and then remove it, something like this. If this dot cur volume is greater than this dot max volume. I'm not saying this is the right way to do it. I'm kind of liking how you did it better. Then this dot current volume is equal to this dot max volume. What I don't really like about how I just did it there is we're kind of correcting the problem after we do it, after the fact. And we're also not letting the user have any way of knowing how much was actually added to it. We could make this method report back to the calling code how many ounces it was actually filled with. So if you called it with 5 and we hadn't hit the max, it would go ahead and return 5. But if it was full and you passed in a 5, it could return a 0 saying, hey, I didn't return anything. So I'm trying to find a balance between making this too complicated and making it Here's what I've got so far. How about this idea? Int space is equal to this dot max volume minus this dot cur volume. I don't know if this is how I want to do it. And then if the amount is less than or equal to the space, then we go ahead and add it to the amount. Now that actually does the very same thing that you did. But maybe it gives us a little bit more flexibility. Maybe we could figure out a way of going ahead and letting it top off. So what do we do if the amount that we want to put in is greater than the amount of space left in the bottle? We could lower that amount. Or we can just print a message, bottle full, Spending too much time on that. The other thing we want to make sure is that we don't pour out more than we have in the bottle. So go to your pour method and prevent it from pouring out. Make sure that you can't pour out more than you have in the bottle. Okay. Same kind of business. I'm just going to follow your general suggestion here. If the amount we are asked to pour is less than or equal to this dot current volume, then do that. Else, I guess I'm going to print an error message. System.out.println, not enough to do that. And I didn't put an error message on the other one. So I could scroll back up here, and on this check, if the amount is less than or equal to the space, this dot current volume, else system.out.print, that would overfill. Alrighty, so as I run it, I see that at least at one point I did get a that would overfill. I'm never going to get a that would empty the bottle message just because of the values I was passing in, right? I never tried to pour out more than I had. So I think on the last pour, I'm going to change that to pour 50. I know that that's not going to work. Oh, I didn't get my error message that I was expecting. Where'd that 50 go? Oh, it's right there. That was the third time we called pour. That's the first time, that's the second time. Okay, there it is. There's my message. Not enough to do that. I didn't make it very noticeable, you know. Our messages about what we are showing don't look very clear to me. We might just want to call display every single time after we do something. We could make this a lot clearer. All right, what I wish I could figure out a cool way of doing would be to modify this application in a couple of ways. And that would be to make the fill method should return the number of ounces actually added to the bottle. If the bottle was full before we called fill, it would return 0. If the bottle was partially empty but could take some more, we would return how many we actually put into it. We'd at least do this part, the return 0, if we don't get it to do anything. So I'm going to go back to our fill method in our bottle, make that a little bit of a change. So if the amount is less than or equal to the space, then we do that, else we do that, and we also need to put a return message in there. You know what, I've structured this in such a way that I think that I don't want to, that I would have to hack and slash it in order to get that to work, and that's not really the point of the assignment. I don't want to, I got stuck on it, forget it. We have our bottle class. Let's work with one more thing along these lines, but we're going to add getters and setters to it. So add a new class to your project. Go to Project, right-click on your package, New Java class. Let's call it Rectangle. And we're going to put two variables in it, two instance variables. We're going to make them private. Private width, but it's going to be an int. And then private int height. How about just H and W? And then let's provide ourselves a get area method so that we can find out the area of the rectangle. Public int get area, and the area of a rectangle is its width times its height. Return this dot width times this dot height, like that. Now that we have that class, let's go back to our main application and create a rectangle and get its area. I'm going to do that, I guess, underneath the bottle code. All the way down here at the bottom under our call to be display. Rectangle R1 equals new rectangle. And int area is equal to R1 dot get area, and let's print that out. System.out. Println area of R1 is, end quote, plus area. I guess I didn't need to break it up like that. I could have just, put R1.getArea right there rather than store it in a temporary variable to print out, but whatever. And of course, it's going to display that it's got an area of 0, right? Because those variables have been initialized to 0 and we don't have any way of changing them. But we can do that. What if we created our rectangle there and then we decided, okay, area.x is equal to 10, area.y is equal to 20. Those are errors. Well, for one thing, we don't have x and y variables. We have width and height. So area.w is equal to 10, area.h is equal to 20, but that still doesn't work. Those are underlined red. Without me hovering the mouse over there, what's wrong? Can anybody tell me? You've got it. You hover your mouse over it and tell me what it says.
Area is not a class.
Well, I was expecting something much more informative than that. Oh, derp. Area is not the name of our rectangle. R1 is. How about R1.w is equal to 10 and R1.h is equal to 20? It's still a syntax error, but at least it'll be the correct one, which is that w is private. Do we fix that by going into the rectangle class and making them public? No, we provide setters, which are known technically as mutators. They mutate the values. So go back to your rectangle class and we're going to add a setter. It doesn't need to return anything, so it can be declared void. It doesn't need to be public so that the client code can access it. So public void set area int, not set area, where'd I come up with that? Set w. So public void set w, w is capitalized, parentheses int w, and we're going to set this dot w equal to w. And if we want to give a better variable name than just w, like width, we could do that. Int width, but then we'd have to change it here too. This dot w is equal to the width. Do the same thing for the h instance variable. Provide a set h method. Go ahead and type that in as well. It'll be very similar. Public void set h int height. This dot h is equal to the height passed in. Now we can actually set those values. Once you get your two setters, your two mutators, I'm going to add some comments. This is a setter, also known as a mutator. This is a setter, also known as a mutator. I'm going to go back to my main code, and where I had r1.w, instead it's going to be r1.setW equal to r1.setW parentheses 10. And then r1.setH equal to 20. Now as we go along and we think to ourselves, that really is a lousy method name. It ought to be set width and set height. We kind of weaseled out. I saved us some typing by making it, just W and H. Let's go ahead and change the name of those methods to better names than just set W and set H. So go back to your rectangle class, highlight the word set W, right click on it, or just click it and then do refactor rename. There's a refactor menu up in the top of NetBeans. So highlight that set W part, refactor, rename, and let's give it a better name. Set width, like that. What that does is it tells NetBeans to go and rename it everywhere. Because if I just renamed it here, right, like this, if I just called that set height right there, it wouldn't have changed it in the client code. But by doing refactor, it did. I'm going to do the same thing to H, to set H. I'm going to highlight that code, choose refactor, rename, and call it set height. Okay, so now when we run our code, it should actually print a valid area. It's a 10 by 20. It ought to have an area of 200. Ho, 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 but it doesn't.
Say 0.
Area is still 0 on mine. What did I do wrong in my code? I'm going to close my bottle class. It's confusing me. Okay. Oh, I called the area before I actually changed the values. Right? You can't get the area until you've already set those things. So I'm going to cut that line. That area is equal to r1.getArea, and I'm going to move it below those two things. And honestly, that was a bad idea to begin with. I'm going to cut that entire line, and instead I'm going to say system.out.println area of r1 is end quote plus r1.getArea. What if we wanted to print out the width and the height, though? We don't have any way. We can set those values, but we can't print them out. System, don't type this because it's not going to work. System.out.println height of R1 is, or I guess you could type it, plus R1.height. We still can't do it. It's still a private variable. H has private access in rectangle. We need to go add getters as well as setters. Getters do have to return something, so we can't declare them as void. So let's add two methods, getWidth and getHeight. Public int getWidth, but you don't pass in any arguments, so you don't define any parameters between the parentheses. And getWidth returns this .w. Now we're also going to do a getHeight. Public int getHeight. Parentheses in parentheses. Return this .height. Nope, not this .height, but honestly I should have called it height. So I'm going to rename those variables as well, those member variables. I'm going to scroll up here, and where it says private int w and private int h, I'm going to use the refactor again to rename those. I'm going to double click to highlight that w and choose refactor, rename, and just call it width. I'm going to do the same for h. And until you publish your stuff and give it to another programmer, you can mess with your variable names like this. Yeah, you call something X and later on you wish you'd given it a better name. Just refactor, rename it, and give it a better name, like current temperature or whatever X is supposed to be at that point. So refactor, rename that H to be height. Okay. Now we can print that stuff out. We're all good there, or do we have syntax errors? Need to walk around. Okay, so let's print out the size of this guy. System.out.println, no, printf, R1 is %d by %d, \n, end quote, comma. Now the %d's mean that it gets filled in by ints. If you want to fill it in with a double with a floating point value, you have to do %f instead. So we have these placeholders here. We're filling them in with ints. What ints are we going to fill them in with? R1.get height, comma, and then R1.get width. End parentheses, end semicolon, and I forgot to put my parentheses after get width, the opening and closing parentheses. So the act of making your data private is called data hiding. And your application and your classes should make their data private so that when you give your code to another programmer or when you're using it yourself, you don't have to worry about that stuff. You shouldn't be able to go in and monkey with those values through any means other than what the class provides you. The class gives you a set of methods with which you should manipulate, with which you should interface with the data of that class. The only way we should be able to change the maximum volume of that bottle is by calling setMax. Not just by saying, okay, dot maxvol equals whatever. Why? Because we may need to, the goal of encapsulation, of data hiding, of putting your data private in there is to make sure that it's always at a good state, so that you can't set somebody's pay rate equal to a negative value, or so that you can't store a negative volume in a bottle, or that you can't store anything in the more than the maximum value of it. And so what you do is you set your data private, and then your methods are the interface which interacts with that data, and you can make sure that that bottle is always in a valid state, that it doesn't have any bad data in it. Let's give an example of that, but I am going to demonstrate a shortcut to you. Oh, I never ran it to actually make sure it works. There's a shortcut for adding your accessors and your mutators. I forgot to add comments about what those actually were, but okay, my R1 is 20 by 10, the area is 200. Very well and good. I could move that to a display method inside the object, right? So that all I had to do is call R1.display and it would display it. Let's go back into rectangle, add some comments. We did add comments for our setters. We said that they were mutators. Our getters are known as accessors. So on both of these get methods, I'm just going to add the comment that this is a getter, which is an accessor. Accessor is the term the book uses, and getter is a term that a lot of people use. Same with mutators, Mutator is the book term, setter is the common, English term for it. Let's make one more class. Let's make a pay rate class. So go back to projects, add one more to your default package, right click, new, Java class. I'm just going to call it pay. I'm going to click Finish. And we're going to do two variables. Private double hours, like how many hours the guy worked, and private double hourly wage. So that's going to be pay rate, just maybe rate. Then my next task would be to provide getters and setters for that. Because I made them private, the only way that the client code could interact with those data would be to give getters and setters. NetBeans will do this for you if you let it. Here's what you can do. Highlight the two variables that you wish to have encapsulated with getters and setters. Then go up to Refactor and choose Encapsulate Fields. And you can see that what it's going to do. It's going to make a getter for each one, and it's going to make a setter for each one. And you click Refactor, and boom, we already have all of our getters and our setters. And it fluffs them out with a whole bunch of comments, and it pushes our variables down to the bottom of the list, which I don't like. So I'm going to cut those variables that are now at the bottom of my class and move them back up to the top. And I'm going to remove those comments. So did I save any real time by doing that? Not that much, since I'm trying to make it look pretty for y'all. But I just want you to see that you can define a whole bunch of variables. You could define 20 variables, and then you could encapsulate them all at once with that refactor. And it would add getters and setters for every single one of them. Now sometimes you don't want to provide setters. Our lab rat example. You don't want to be able to change the rat's weight, in mid-simulation. So you wouldn't put a setter on the rat's weight. Same for its age. The only time its age and weight should increase is any time that you call grow. The only time that our car's mileage and gas should change is when you call the drive method until you go back and add a fill method, something like that to put more gas into it. So along with our pay, let's write a function that'll calculate the pay. So let's do, needs to be public so that we can call it, needs to be double so that we can return a value. And let's not take into account time and a half yet. So all I'm going to do is I'm going to declare a variable called pay. I'm going to set it equal to hours times rate, and then I'm going to return pay. And I'm being slightly inconsistent here because everywhere else I've always insisted we type this dot. So more correctly it should have been this dot hours and this dot rate. I think I'm just going to leave it like that. Get y'all used to seeing it both ways. So I'm going to build everything, make sure I haven't introduced any syntax errors, go back to my Java application, and after I create my rectangle, I'm going to create a pay object. Pay P1 is equal to new pay, and now I'm going to call the setters for him. P1.set hours, this guy works 40 hours a week. P1.set rate, he earns $20 an hour. And then pay P2 is equal to new pay. We're going to have two payroll objects we're keeping track of. P2.set hours. This person works 30 hours a week. P2.set rate. This person works for $15 an hour. And let's print out their pay. System.out.println printf. P1 earns $%.2f because we want it formatted to just two places after the decimal point. That's what the .2 means, two places after the decimal point, and f means that it's a floating point number, like a double. And then \n, and then after the quote, comma, P1 dot get pay. And do the same thing for P2. And that was a lot of typing, so I'm going to cheat and I'm going to copy that printf statement, paste it, and change all the P1s to P2s. Now when I run it, hopefully it'll say how much each person's earning. A 40-hour-a-week person's earning $800, the 30-hour-a-week person's earning $450. All right, I hope this is starting to gel. I hope it's starting to fix cement into your brain. We have these classes. Pay is a class, rectangle is a class, bottle is a class. Each class defines a set of data. Those are the instance variables. How much the bottle can hold, how many hours that person worked, that rectangle's height. And then it has some members, some methods that interact with that data. Something that can get the pay rate, something that can get the number of hours worked, something that can set the number of hours worked. So you can provide default values for your variables as you create them, your members. If you want the default value to be 0, that's already the case. So when I went over here and in my pay method, I didn't give any default values, so they default to being 0. If I wanted to, I could give some default values. I could say that as soon as we create somebody, we're assuming they work 40 hours a week unless otherwise told. And the same for the rate. We could say as soon as we create them, we're going to assume that they get $10 an hour unless, And so the reason that you might want to provide default values is so that you have some valid data sitting in the object. Now, I'd rather the program go and actually have to specifically set all that stuff, probably. We could have done the same for our rectangle class. Our rectangle class, we initialized it so that the height and the width were 0. But we could say, okay, every time you create a rectangle, it's just going to be a 1x1 rectangle, like that. So we could modify those default values. You just have to think about what's the most useful. Do you want the client code to have to set everything before it starts operating or not? So instance variables do get default values even if you don't provide any. Integers default to 0. Floating points like double and float get set to 0.0. Booleans default to false, and reference types like strings all get set to null. So a variable's persistence is how long the variable value survives before it's wiped out. Instance variables persist for the duration of a particular object. If an object makes 2 method calls, the second method call does not reset the instance variables to their initialized values. It keeps using. So what is that saying? That is saying, let's go, oops, I opened the wrong one. Remember here where in our primary class, we created a rectangle and we set his height to 20. If we change that, if we then went along and did r1.setHeight to 30, does that change the width of it? No, that data is persistent. The width of it is persistent. It stays the same. We are changing values, other values inside that class, but that doesn't change this one's. And that data is available to us as long as this object is around. We've kind of seen that concept before. I'm just going to write a dumb statement here. If chur x is equal to 3, and then system.out.println x. I didn't give x a type, so I'm getting a syntax error. All right, that's an obvious error. What is wrong with it? Yeah, you see X, it's not available. It no longer exists. It is defined inside these curly braces, and so that's the only place it can be accessed. Same is true of an object. If I create a new payroll, P3 is equal to new pay, and then down here I try to set that equal to something, P3 dot set, hours to 20. Not going to work. P3 no longer exists. So what is actually happening behind the scenes, and this is what's known as a local variable. A local variable is one that's defined inside a method. Everything we've seen actually is local variables, except for our instance variables. This is not a local variable because it is not inside a method. Neither is that, but this is. That's a local variable. Once this function is done, that variable no longer exists. So if we wanted to do anything with the value that was being held with it, we'd better return it so that something else could use it. Otherwise, it's just completely gone. Here, we actually create an entire object. We create a reference to the object, then we create the object itself. And we assign the address of the reference back into that variable. But then we're saying, oh, okay, by the time we get here, we can no longer access that. The object, it's like you have a house on a street, but then you remove all the street signs. You have no reference variables pointing to that house anymore. The house is still there. In older programming languages, or in certain programming languages, that could be a problem. That memory would remain allocated. You might have a loop that's making a new payroll person, and it creates 10,000 different employees so that you can print out 10,000 different checks. And then after that's done, you have 10,000 new objects floating in your computer's memory. The longer the program runs, the more and more memory it uses. That's what's known as a memory leak. A memory leak is when a program allocates more and more memory as it runs and it never releases any of it. And the Firefox browser used to be notorious for doing this. They fixed it a long time ago. But if you let it run for a couple of days and you came back and then you checked how much memory it was using, you would be using all the RAM that was available on your machine. So a memory leak is when some memory is being allocated, like when you create a new object, but not being released. In Java, that's not really a problem because Java implements something known as garbage collection. Periodically, the Java virtual machine, the runtime engine goes and looks, oh, do I have any objects that are no longer being referenced? Oh, good, I can delete them. I can throw them away. I can wipe that memory. I can free that memory. So in this case, we create an object. That object still exists, but the reference to it is gone. And so when we try to access it like that, we can't. It's called an orphaned object. There's no way to get a hold of its data anymore. And the garbage collector comes and erases those orphaned objects so that you don't have memory leaks where your program continually expands, growing. Other languages, like the C programming language, you have to be very, 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 very careful. You have to deallocate everything you allocate. So for every new keyword like that, you'd have to have some kind of delete keyword that matches. So this slide here is talking about persistence, how long that variable's value survives until it's wiped out. Well, the object continues to exist until all references to it are removed. It's called falling out of scope. If we have our code here, and this will be the last thing we talk about, it looks like. X is in scope here. You got a hunting rifle with a scope. It's out of scope down here. The scope of that variable is only between these two braces. Same for the P3 variable. His scope is only between these two variables. So here P3 is out of scope, and that's why we can't access it. The scope for an instance variable, a class member, like height and width, part of the rectangle class, every method inside that class can get a hold of width and height, which is good because otherwise how would you calculate the area? So the instance variables scopes are the scope of the entire object itself. whereas a local variable scope is only within the pair of braces in which it's defined in that method. Hope that makes sense. So what we're going to do as far as, let's make a Dropbox for this. I should stop talking because it's actually time for us to go. Do I have another class assignment ready for us to go? The block class. Do we know enough to assign this? Create a new class called block. The block class has 3 data members, height, width, and depth. It has 2 methods, get surface area and get volume. Look up those formulas if you need them. Or ask me if you don't. And then create code in the main method that creates 2 block objects, sets their height and width and depth, and prints the surface area and volumes of those objects. Yeah, we know enough to do that. Right? I'm not seeing anybody go, no. So, yeah, that'll be our homework for this. And since we have one due from next week, we'll have a little bit more time available on this one. And we need a Dropbox element OP. Alright, if you refresh your Dropbox, you'll see Dropbox P. Go ahead and put you should have 4 .java files you created. Either upload them individually or zip them up all into one. So, any questions before next Tuesday? Nobody's making eye contact, so I guess not.